Okay, so we're going to switch to our next panel about research centers at Stanford Data Science and just different ways for folks to get involved in the different thematic areas that these research centers provide space for. So I'll just invite the panelists up, I think, right? But before that, I'm going to introduce our moderator, Elizabeth Wilsey. She's our Director of Partnerships and Engagement here at Stanford Data Science. She's the lead of our corporate affiliate program, but also helps to direct engagement across campus, in particular the creation of research centers and working with faculty leaders there. So yes, Elizabeth, are you going to introduce people? Or? Okay, come on up.
All right, thank you all for joining us on a panel today. So I'll do a brief introduction of our panelists. Following that, we'll have an opportunity for each of them to give a short overview of their research center and the perspective that they're offering to campus. And then we'll have some chance for some conversation and dialogue, things that you've learned through the research center, exciting discoveries. And then we will take questions over lunch for the research center. So we'll start with Tom, who's on the end. So Tom Abel is a professor of particle physics and astrophysics. He studies the origins of structure in the universe through advanced computational astrophysics, and his group develops pioneering supercomputer simulations to explore the first stars, galaxy, cosmic phenomena, such as magnetic fields and heavy elements. And some of his research has helped reveal how the earliest luminous objects formed and how dark matter shapes the cosmos. So thank you, Tom. Next up, we have Ramesh Johari, who is a professor in the Department of Management, Science, and Engineering. He works at the intersection of algorithms, economics, and societal systems. His research focuses on market design, data-driven optimization, and the societal impact of digital platforms. And he is affiliated with the Social Algorithms Lab, the Information Systems Laboratory, the Cyber Initiative, and our very own Causal Science Research Center. Oh, I should mention that Tom is representing the Center for Decoding the Universe, which is a joint center with Stanford Data Science and SLAC. Jumping to David Lobell, who's next, is the Benjamin M. Page Professor in the Department of Earth System Science, and he investigates global challenges of agriculture, food security, and climate change. He is representing he is director of the Center on Food Security and the Environment and Sustainability Data Science Center at Stanford, at SDS, which we affectionately call SUDS. So if you hear that, you may hear acronyms throughout the whole panel. And he leads efforts to apply data science to improve rural livelihoods and sustainable development. And his work uses satellite imagery and statistical models to assess agricultural progress worldwide. And next to me, certainly not last or least, is Maya Mathur, the Associate Professor in Quantitative Sciences Unit within the Biomedical Informatics Research Division and the Department of Pediatrics over at Stanford Hospital. She is a statistician specializing in meta-analysis, evidence synthesis, and causal inference. She also directs the Stanford Humane and Sustainable Food Lab and serves as Associate Director of the Center for Open and Reproducible Science, which you will hear referred to as CORS today. And her contributions to biostatistics and epidemiology have earned recognition from leading professional societies. So thank you each for being here. And I think we'll just go in the other direction to start. So starting with you, Maya, if you could give a brief overview of CORS so that our audience knows who we're talking to today.
Okay, great. So CORS is one of the relatively younger centers. It was started in 2020 by my colleague Russ Poldrack from the psychology department. And really the goal is to serve as a kind of training resource platform for open science and reproducibility practices to spread throughout Stanford and to be feasible for investigators across many different disciplines so that we can all learn from advances that perhaps other disciplines or colleagues are using and try to pull that into our own work. So our focuses are primarily on kind of training and practical sharing of advice. So one of our big initiatives is to have open science project offices, which serves to essentially connect the open source, open science communities, and to provide roundtables where folks can actually get their concrete questions answered and to connect that way. So that's one of our big initiatives. We also have been partnering with other entities within the school, like the Door School for its new Taking the Pulse of the Planet initiative, so helping to really integrate open science at the beginning of some really important research that's starting.
You want me to go
We'll
to?
just go down the line.
Okay. So SUDS is, well, Maya just mentioned the Door School. So for those who don't know, it's the new school and the university focused on sustainability. We have a long history of sustainability research at Stanford, but this is a big new investment. And what SUDS is trying to do is really two things. One is to sort of make sure that the researchers focused on sustainability are using sort of the latest and greatest data science methods, but also to sort of have the community focused on data science, computer science, understand the types of data and problems that we're working with in sustainability to try to inspire the next generation of sort of methods. And so a lot of what we do is try to build community, really create the spaces that people spend time learning about each other. So we have an annual student conference. We have actually a small group of PhD students that are meeting very regularly. We've run classes. We have a lot of sort of student-focused things. We've done some things at the faculty level as well, but we're really trying to just sort of create awareness and have people put in that time that we think is really going to result and has resulted already in a lot of new ideas and new directions.
So I'm Ramesh Johari, and as Elizabeth mentioned, representing the Stanford Causal Science Center. Our acronym is SC2, or SC to the second power. We're similar, I think, to the way Maya described it. One of the early centers of Stanford data science, started by Hito Mbens, who's econometrician. Many of you know, won the Nobel Prize in economics. And I think there's something Hito did when he started the center that was really, in retrospect, turned out to be quite a genius move, which is not to call it the Causal Inference Center. It was really interesting because causal inference is a field, very mature, has a large sort of range of representation from a number of disciplines. But by calling it causal science, I think he actually cast a much wider net, a much larger umbrella. And I think, you know, the right way to think about the center is it is a sort of uniting spot for all research and applications that involve causality. And what is causality? Measuring cause and effect and making decisions based on cause and effect. I think there's a number of events that target that community on campus. So we have, for example, a conference which features student presentations every fall. We have a number of mixers for students on campus. We also host Bay Area Tech economics seminars in conjunction with a number of other both industry and academic collaborators. There's an online causal inference seminar that actually started during the pandemic that often has hundreds of attendees from around the world on it every Tuesday morning. In addition, I think the other thing that's been exciting about the center is connecting sort of that theme, that kind of broad question area of research across the boundary from methods to applications and back, actually very similar to the way David described it. In fact, sustainability is one of those applications that frequently see represented at our events. And so, that's an interesting, for me, actually, it's a very exciting aspect of it because you often have, let's say, students that are, they've been thinking very deeply about an application domain, and you need methods to help you assess, say, causal effects in a domain you're working in. Conversely, you have methods researchers on campus, and those of you, I'm a methods researcher, I'll just openly admit, and if you're a methods researcher, you know that you are often a hammer looking for nails, and so, so it's great to see that happen, that kind of connection happen, and then also connections outside. We run a conference every spring that we call the Conference on Experimentation, which really has become a really fun industry academic gathering spot. So we have it coming up on May 23rd. If at all anything like I'm describing here sounds interesting to you, I'd highly encourage you to attend. It's going to be a great lineup again. And so we sort of use that as an opportunity to make sure that there's ways for our community at Stanford to benefit from problems that exist in this ecosystem around us, and conversely for those in the ecosystem around us to find appropriate points of entry into addressing those types of problems using the kind of research we're doing here. So happy to talk more about any of that, but that's kind of the broad overview. Over to you, Tom.
Yes, so I'm Tom Abel. I've been here over 20 years. I'm both a professor up at SLAC and here in the physics department. And our center, the Center for Decoding the Universe, has also an acronym. It's C4U. So the whole idea is to be inclusive. And we just started last fall. Risa Wexler is the director, and Susan Clark, the co-director. I'm on the executive committee. And so we just started getting going. We have quarterly events, and we'll have a conference June 5th and 6th in this room. But it all grows from an effort we did over the last 20 years of starting a new center for astrophysics, the Kavli Institute for Particle Astrophysics and Cosmology. And that's a collaboration between SLAC and campus. And we've built some very large instrumentation. We flew a gamma-ray space telescope. We now installed the largest digital camera in the world, a 3-gigapixel camera on an 8-meter telescope. It's going to produce 20 terabytes of data every night. And we just got the first images, and it's extraordinarily exciting. So there's a 10-year period where we'll take a movie of the universe. And so the timing is really perfect. And this is really just one example, but one that very dear to our heart. It's local, it's our hardware, and we want to make the most of it. But it's an exciting opportunity. Also, there's a bridge now to use all the new technology we're getting, with help developed by industry, to combine with the incredible data we're generating to create new insights. And that's the sense of the name, the decoding part. And yeah, don't get me started. I could really geek out a long time on this. Anyhow.
Thank you, each of you. So now you have an idea of the different perspectives that we have in front today. And I think the next place where we'll go, you've all brought up this sort of boundary crossing element of the research centers, whether it be methodologies plus domains or across different disciplines. And I'd love to hear you talk a little bit about how the cross-disciplinary work that's happening inside your research center is fueling discovery. Maybe we'll start in the middle this time. We'll start with you, David.
Okay. Let me give an example. Maybe that'll be helpful. So recently we had, okay, let me step back. I think there's particular types of data and particular types of questions that some fields are sort of very common, like the biomedical examples that Rob and Trevor and others have worked on a lot are a good example of that, where sort of there was a setting there where there was lots of variables, not that much data, you want to interpret the coefficients, et cetera. Now, sustainability has all sorts of types of questions, but one of the very common sources that I work on and many others is like imaging. You have a lot of images, you don't have that many labels. And we were working, in this case, with Stefano Ramon's group, trying to understand sort of how do you work in that kind of environment where often we're trying to predict something on the land surface. And out of their sort of other work, they were very familiar with a lot of the text-based methods that were going on. Diffusion models, masked autoencoders, low rank, fine-tuning, which was really helpful. And so one of the master students in computer science, Summer Kana, he did a series of papers, one applying masked autoencoders to satellite imagery. That paper actually ended up being picked up by IBM and many other companies to sort of develop the foundation models around imaging. And then he, along with an undergrad, Medhani Irgal, looked at using low-ranked LoRa methods in a pre-training task to further increase sort of the accuracy and reliability of these methods. So these are now basically packages that we have to improve all the predictions we're making in many cases very remote areas where we have very little training data that came out of sort of their familiarity with other methods. They couldn't just use them off the shelf because these were text-based methods, but they reapplied them to the types of satellite imagery. I think that sort of answers your question, and the kind of thing that like we wouldn't have thought of, they wouldn't have thought of. And it took, Stefano actually and I talked together, and it took like many times of going back and forth to understand each other's language. But that was the kind of example of a result of that effort.
Stay in the middle, Elizabeth? Is that all right? Yeah, so I'll go next. Yeah, it's kind of interesting, actually, to me, even at the sort of level of leadership of the Causal Science Center, and Hito, and so Hito, myself, and then Stefan Wager is the third co-director. We've talked about this frequently. Stefan is a statistician by training. Hito is an econometrician by training, and I'm an engineer, operations researcher by training. And all three of us have this sense in which you sometimes feel like an outsider at the aspects of your problem that you're tackling. So I think for me the center's sort of from the top exhibits this kind of cross-disciplinary flavor. One maybe thing I'll mention is that I'm actually on sabbatical this year, and I'm spending my sabbatical over at the GSB around Stefan. That did not go very far. My students give me a lot of crap about that. And one of the collaborations that we built through the Causal Science Center is a postdoc program that we've been launching with Airbnb. It's actually proven to be a very interesting sort of specific point of evidence in this direction. Maybe one sort of concrete anecdote I'll tell is that I became interested in causal inference, causal science, as a market designer. So I thought about online platforms for quite a long time. And online platforms, almost any intervention that you're going to generate and test, you're going to use experiments, A/B tests to evaluate that. And so the methods we use to run those experiments, to determine causal effects from those experiments, that's causal inference. One of the things that kind of stands out to you if you're around this ecosystem at all is that those are often treated in isolation. There's very little sort of chained thinking about how multiple tests build on each other, inform each other. And sort of what's neat is if you start thinking about multiple experiments in sequence, then what used to be sort of a classical causal inference problem turns into a reinforcement learning problem. And so now, we have a new range of sort of techniques and models and ways to think about the problem, especially if you're thinking about sort of the long-run consequences for an organization that's building out experimentation programs rather than just individual experiments. And so, without going too deep into the weeds, again, like Tom, we could probably spend the whole hour talking about methods here, but I think one of the interesting things in collaboration with Airbnb has been the emergence of this theme of the role of experiments not just as sort of one-off scientific tests of a hypothesis, but actually as components in an online decision-making program. And so I think from there we get from the narrow statistical elements of evaluation or the narrow econometric elements of evaluation to more the engineering aspects of experimentation as a reinforcement learning system. So for all three of us and then the postdocs that we're bringing in and our partners at Airbnb, that's been like a very exciting way to think about some of the challenges that arise. So I'll leave it at that level. Yeah. Tom or Maya? Yeah.
Sure. Yeah, so on the course side, I'll start with kind of a higher level example and then a more specific one. So one thing we've been trying to do to establish interdisciplinary collaborations is just recognizing, helping people to realize that open science is a principle that can apply to many different disciplines. So to that end, we have an annual meeting every year where we give out prizes to members of the Stanford community, both more junior people as well as more senior individuals who've exhibited really good open science practices in their work. And so we've actually had winners from many different disciplines. Last year's was Robert McCune from the law school. So just trying to highlight the fact that there are many different ways to do open science depending on the discipline that you're in. We had another, one of the junior winners had a very interesting project on kind of refurbishing historical documents. So not the traditional kind of science that we usually think of as being open science. So that's kind of one higher level thing. Lower level thing, I'll return to an example I started saying earlier, which is a new collaboration with the Door School. And this was really spearheaded by our own Zach Chandler, our director of open science strategy. So there's an initiative at the Door School called Taking the Pulse of the Planet, and this is led by Rosemary Knight, I think, right? Yeah. So the idea here is to design new, like, nationwide sensor infrastructure to keep a close eye on climate change and other aspects of sort of ecological change that are happening. And it's a brand new initiative, so it's a really exciting opportunity to start from the beginning. And so Zach's been collaborating with their group, and he was telling me actually one interesting thing that happened was that their group had not necessarily heard of open science practices that are very common in biomedicine, for instance. And I'm sure the same is true, I'm sure the converse is true as well, that we haven't heard of things that their type of research entails. So just the ability to bring advances from one discipline in open science to others, I think has been a key focus for the interdisciplinary collaborations.
Yeah, there's so much to say, but let me, in astronomy, we have this crazy dynamic range. You know, stars are 1 trillion times smaller than a galaxy, and we've got trillions of galaxies. It's kind of amazing. So very often, for years, you know, when we organize things, or I do simulations, I need quadruple precision just to describe where stuff is. Like, and so there's all these bits that we used to do, you know, that we really had to custom write for our own. But I get the sense now in industry there's a lot more going on, all the digital twins that's happening, like the way we organize data, how we actually do different representations. You know, I'm really excited about the Gaussian splat business going on and voxel-based, sort of more mesh-free bits. I think there's so many contact points now where it actually makes more sense now than it would have 10 years ago to come together, think about representations, organize the data, and then, you know, really put it all into a digital twin and treat, you know, the city digital twin just as one subset of the universe one. And, you know, and the same thing with your red blood cell of where it's going to fit. You know, we need the technologies to reason about these things across all the scales together, and that makes this easy, but also just immense. Like, I mean, there's so many connection points. But, you know, that's the excitement, and that's why we're here, I guess, yeah.
So one of the other things that you each talked about different convenings, different ways that you're bringing people together, but there's also pathways inside each of the centers where you're thinking about education and thinking about how the data scientists that are being trained here at Stanford are becoming part of the way of thinking of this interdisciplinary way of thinking that you have. And it would be great to hear a little bit about how these research centers help to prepare this next generation of data scientists that are going out into industry, they're going out to other universities and thinking about the changing landscapes that are ahead of us and how that fits with the concepts of the research centers that we have. Anybody can pick this one up.
Yeah, it's interesting. I saw this on our list of questions, Elizabeth, and I was a bit worried, honestly. You know, I think that there's kind of two levels to this answer. I mean, one is I think the obvious one, which is certainly what I've observed in the student population. So, for example, I mentioned the student conference we have in the fall. Usually it's like sort of 16 to 20-ish presentations and then additional posters as well. One thing that's just been evident in watching that conference evolve over the last few years is the increase in the number of submissions. And that's always a good sign. It's a healthy sign of a community growing. But I think part of the reason that's also like happening and beneficial is that I think more students today, certainly than when I was a graduate student like 2 decades ago, I think they see that insularity is really not a winning strategy. And so I think at some level, like what you're hearing from all 4 of these centers is that that's actually something the students want. It's not even just because we faculty love to get together and do something new. I think the students today recognize that you can't graduate with just one narrow skill set. And it's actually interesting to me as I was listening to all of you talk. I mean, Maya mentioned causal inference, or maybe Elizabeth mentioned in Maya's bio. David is, and I think we've had lunch multiple times at Causal Science Center events. We actually hosted a group from C4U in a causal machine learning lunch series that we were holding last fall to learn a little bit about gravitational lensing and sort of connections to causal inference. All of which is to say that, you know, I think that even beyond the individual center boundaries, there's this sense in which for the students, they're looking for that, they want that. The other thing I want to mention is just to put on the radar screen something that we've been playing with in the Causal Science Center is actually putting together sort of mini courses that would serve as pedagogical material around topics in causal science and causal inference. And I think partly with a view towards this, Elizabeth, of expanding kind of educational impact in this domain. So I won't say it's much more about that right now because we're still in the planning stages, but that's something we want to roll out over the next year.
All right, I can go first, Ramesh. I definitely hope you do the mini courses. I would say probably 80% of the students who work with me ask for something like that, so I definitely hope you do it. Okay, so on the course side, a few different points here. One is that we've long had a student ambassadors program, so it's essentially an affiliation that students can have with cores, where our goal is really to reach out quite broadly to different disciplines, different departments, to have students who are really engaged in the mission and who help not only shape the teaching that we do, but also to help disseminate these types of practices to their own departments. It's often the students, right, who are actually pushing the frontier of open science and kind of like changing their own PI's structure. It's not so much the faculty often who initiate these things. So that's one. Second, we did, throughout 2021 and 2022, we did a series of open access lectures, which were given both by CORE's directors and also by our various affiliates and other faculty members and students, which were focused on both the concepts and principles and the concrete implementation of open science practices. So that was a way to kind of provide a starting point of learning materials for our community. A more recent thing is an initiative towards what are called living textbooks. So this is the idea of a textbook that, rather than just being printed once and sold on Amazon for an arm and a leg cost, rather a textbook that is sort of written online. Perhaps it's even version controlled on a platform like GitHub, and so it can be easily updated, it can be easily accessed by anyone who wants to look at it, can be easily commented on. It's more of a living document. So our director, Russ Poldrack, has written a book called Statistical Thinking for the 21st Century, which is exactly like this. My collaborator, Mike Frank, also led one that I was involved with called Experimentology. So that's open science and statistical methods for the social sciences. So both of those follow that living textbook model. So we're very interested in kind of how the idea of openness and that ethos can also penetrate to education and not just individual research practices.
I guess I'll give a couple thoughts. I guess in my brain, I think of this almost like a 2x2 matrix, since this is a data science conference. You've got sort of the undergrads and the PhD students, with maybe masters kind of split between. And then you've got the students sort of basically coming out of the statistics, computer science background, and then you've got the students on the sustainability background. And I think in each of those quadrants, there are sort of different needs and sort of different efforts that we've made. I think we started mostly on the undergraduate CS statistics students because there was such a large population, many of them coming to us saying sort of they didn't want to work on advertising and web sales. They wanted to know what else is out there. And so for that, it's really about making them aware of what the grand sustainability challenges are. They've certainly heard of climate change, but what are the big challenges and what are the questions that people have? And we had offered a course many times where we actually have projects that they work on in teams. Often then they submit to conferences, and it helps them, I think, get that awareness. On the other end of the spectrum, you've got the PhD students in the sustainability side. And one of the things that's, I think, interesting and different than when I was a student was that you have many labs now that have one student that really came from a CS stats background, decided to go to grad school in sustainability, but don't really have their advisor or the other peers in their group with sort of the background to give them very technical feedback. And so we've been trying recently to create sort of a network that they can lean on each other and also cross over to the stats PhD students. I guess I won't go through each quadrant. I mean, I wouldn't say we're trying to tackle everything at once, but I do think on the stats and CS PhD student side, to be honest, it's really difficult right now to engage them because there's so much excitement and so much activity. Many of them are, dropping out, going on leave, et cetera. So that is a challenge. But I also think for the ones who really are committed and engaged, just getting that culture of this is something when I was a grad student, Paul Switzer told me, I don't know if many of you know Paul Switzer, but he said, being a statistician working on environmental problems is a lot more than just being a good statistician who's interested in environmental problems. You have to have the personality and the disposition to spend time to learn, to ask questions. And so just creating that culture, I think, is it's something that Stanford does well already, but I think we want to just continue to sort of build that and model that for students over time.
Yeah, I don't have too much to add other than saying what really resonates with me are the tutorials. And I think we're having a paradigm shift now with, fitting billions of parameters to our observations, which is really great. And I'm thrilled about the idea that we can do all these inverse problems, that every observation of the universe I can relate to a 3D version that would look exactly like the thing I'm observing. And so really argue about the physics, is truly exciting, but it's a total paradigm shift. And we don't have the textbooks for it. We don't have the examples. We'll have to write walk people through, simple sets building up to that paradigm shifting way of doing the science.
So a couple of the centers do awards. You mentioned the awards a little bit, Maya, and I know that Sustainability Data Science Conference has awards too. And I'm curious if you've seen an impact of those, or sort of the opportunities where in the convenings and in those sorts of settings where you're seeing the students come together on particular areas of emphasis, and just sort of the significance of those convening opportunities.
Sure. Okay, so determining the impact of awards is a hard causal inference problem because we don't necessarily know if there's reverse causation where folks are already interested in open science and then we gave them an award and they continued. But that said, the goal is kind of both to elevate the work of folks who are already doing this, as well as to maybe incentivize those who aren't, as here's an actual concrete CV item that you might be able to earn. I mean, one thing that's challenging about open science is that, especially for faculty, right, it's not really built into the promotion process, the tenure process. It's not something that's formally considered. And so there's sort of a paucity of incentives to actually do that. And so something that actually, goes a little bit in that direction is helpful. So we started doing the awards in 2021. So we also have a sample size issue of, don't have quite enough of a longitudinal cohort to really say too much about the impact. But I think it would be interesting to follow up at least qualitatively with some of them and try to see how that's impacted their work.
I'll just add briefly, I do think it's just a fun way of recognizing. I think it's a fun way of celebrating and creating that culture by example. Also for the judge, we have a bunch of students serve on the judging panel, and just to getting them to think about what actually makes a really good example of a kind of a crossover between really good data science and really important sustainability work. And so it's just I think an opportunity to just model that.
So I'd love to transition at this point with an opportunity for you to ask each other a few questions, because we don't always have all the centers in the room at the same time. Maybe we can start with you, Maya. I know that you had a question.
Sure, although David had the question first. So we should
sure.
I'm trying to, we had a little email exchange that I have to remember now. I think my question was, how do you best engage, especially as I was saying, the level of busyness right now, it's always been high, right? But the level of outside opportunities and just excitement. We've had faculty go on in our center who are involved go on leave. We've had PhD students drop out and go, start companies. Given that, when we've held events certainly at the faculty level and then even at the student level, we're disproportionately getting people from the sustainability side. And so just a question for the centers was, have you found similar things? Do you find that, not sustainability, but people from the domain side are very eager to kind of learn the best methods. People from the method side have plenty to keep them busy, and they're not actually seeking out new problems as much as they might be otherwise. I don't know if that's been a common issue, and if so, what have you found that truly works? We've had a couple of things work better than others, but I'm just curious what has worked well.
Actually, I was wondering, Tom, if you wanted to talk about the event, the forum that you guys held. My daughter actually attended that. She's in high school and said it was incredible on the score. So maybe you can comment on that a little bit.
Yeah, so we do these quarterly forums. So once a quarter, we come together and we put the effort in, like, go really deep and find all these colleagues that we haven't met yet. And so we've only done 2 so far, and it's been good. And I think there's a little, astronomy is romantic and it's pretty and it's open source. And so we have good uptick, I think, for a first or a second meeting. But it's definitely hard to do a sustained thing because it is it's a complex domain. And you have to think about it. It's not where you come in, data have issues, there's so much to think about of what are the selection biases, what did you actually look at? And so you can't just bring your hammer and be done, put in a couple of nails, write the paper. And so it is a lot of work, and so I think over the, as in many other, it's either the personalities, it's just the people get along, or there's really a monetary incentive. Those are the 2 things that work really well to keep the sustained engagement. And I personally always found that, I always need 3 years for a deep collaboration. I can, get across different sort of jargon perhaps within a year, but then, then we formulate the problem. And by year 3, we might actually have something really cool already going. But it's very rare that it's much faster. And so I'm curious whether that anecdotal thing about my last 30 years matches your experience or not.
Yeah. So I saw when David put this question in email, and I thought about it a little bit. I'm going to offer what sounds a little bit like a cynical take, but in my view is actually a very optimistic one. So I think in general, and maybe let me start with the following, right? So a very common thing we do at universities is we ask students, hey, what do you think? Is this thing useful? And I'll be honest that actually a lot of activities, despite what I said a second ago about students knowing they shouldn't be insular, a lot of activities that get students out of their bubble are not well reviewed, okay? Now, why is that? It's basically because of what David said. Everybody's really busy, and you have a thing you have to do that day. And being asked to go to this other thing, like the Data Science Scholars, for example, is a program where you have to be there for some amount of time every week. Maybe that's not the thing you want to do that day. And I thought about this for a while, and what I realized is, that's a sign we're doing something right. Because I think these kinds of activities, to Maya's point, I actually think measuring causal effects is extremely difficult. Because the whole point of a university and the whole point of centers like this, I think, is that you create many collisions. So that maybe I can't trace the causal effect of something I'm doing, the gravitational lensing from that lunch that you guys came and visited for, but it absolutely opened my eyes to a whole range of problems I hadn't thought about before. Right? And actually I remember 4 years ago, Tom, we were on a Zoom call talking about an SF grant, and that's the first time I heard you mention the potential for 20 terabytes of data showing up in one night. And even that, right? Those kinds of things, they stick with you. They're moments that can change trajectories later in ways that you don't attribute back. So in our case, I think, our case being not just me, but all of our centers, I think these SES centers, I think actually it's important to recognize that sustaining, no pun intended, David, the sort of leadership and willingness to create that community. The fact that people keep showing up, I understand people go on leave, students change, that we're living through dynamic times in a lot of different ways. But the fact that there's a sustained level of interest in those communities, despite all the other ways in which our time gets fragmented, I actually think in and of itself is probably the best you hope for at the university level. Because you just never know. You can't account, I think, for all the different ways that those collisions create impact downstream. So I guess the cynical take is, it's actually hard, I think, to point to specific collaborations that happened because this person met that person at a conference or center event, in my case, I'll be honest. And at the same time, the sort of net causal effect of having done this is unambiguously very large and positive in my view, right? So how do you reconcile those two things? And I think it comes down to what I'm saying, that at the end of the day, the goal is that more people get to know more things and more other people than they knew before the centers existed. And that, clearly, very much so, has been the case over the years of existence of the centers. So I'll stop there. I don't know if that sounds, I ended optimistically, right? So yeah.
We should just, in a sense, not be so hard on ourselves. We're creating community. It's a public good. And we could probably do it a little bit better, but the fact that people keep showing up, that means they're getting value out of it.
That's my view.
Yeah. And I should say that, I mean, people keep showing up in part, in my experience, because Laura and her team do such a great job of putting all these events together. I mean, I think for me, that's one thing SDS has made super easy for us as faculty. Like, we're building community, but really what we're having an idea, and then other people are really implementing that community building, which is really, really helpful. I don't know if you had any.
Yeah, okay, definitely agree with the points already raised. So one thing we've been doing at CORES is, I mentioned, open source project office is OSPO. And so this is an initiative that has multiple components, one of which is a recurring maintainers and contributors roundtable. So it's an opportunity for those working on open source projects to actually sit together, think about solutions together, and engage with others who are as deeply knowledgeable about the open source space as they are. So actually, I'm curious, Zach, if you have any sense of attrition. I mean, I think it's definitely been picking up steam in terms of attendance. Do you have a sense of how much attrition or turnover there's been?
Well, we've had people, move on because, postdocs go somewhere else, hopefully. But our numbers we have triple the number that we started with. So we started with about 13 at launch time.
Let me give you this.
Sure.
Yeah.
Sorry. So the Maintainers and Contributors Roundtable, as Maya said, is a group of coding leads across the university from labs that don't normally have peers. But we bring them all together. We typically have 13 people at any one meeting, 48 total membership, and we started with 13. So we've grown quite a bit. And it's a standing invitation to any one of you that are either the coding lead in your lab or want someone to find us. It's a wonderfully interdisciplinary space.
Thank you, Zach.
Can I ask you a question?
Oh, do you want me to ask mine? Oh, sure. Yeah, I guess my question was, just at a meta level, are there things that you all have done in your center that either worked much better than expected or much worse than expected that, perhaps we can learn from?
We're short on mics on this. We're gonna
Oh,
let
yeah.
we're gonna let David go first, actually.
Let's see. I'll maybe give one of each. I mean, better than expected. When we started teaching this course, this capstone course, we had undergrads apply, and then we admitted certain undergrads. And then we came up with some project ideas that we thought would, keep them busy for 10 weeks, give some indication of like whether there was anything there in the idea. And the first couple of years that we offered the class, like not only did the students make progress, but like half the teams wanted to keep working on it the next quarter. I think half ended up being published in conferences. Like, it was just amazing, both the motivation and the the skills that they had that really went well. I think on the sort of maybe lessons learned, I kind of alluded to it already, but we've had many events at the faculty level trying to get small groups of faculty together to really understand what each other are doing, and mostly we had people from the sustainability side show up. So I think what we're going to try to do now, learning from that lesson, is very strategically target new faculty that are coming in that have interests, and then also try to link directly with, you already mentioned the Pulse of the Planet. There's actually a suite of different, like what's called the accelerator flagship destinations, but basically very focused topics that have like 8 to 10 seed projects. And I think what we'll try to do is get direct connections between those projects and maybe even like have a template for them to like explain and advertise the types of problems and data that they have, so that we can maybe better engage at the faculty level. So we have a lot of lessons to learn about faculty level engagement. I'll just leave it at that. We have a lot of lessons at the PhD level too, but I think there's a lot of great students involved, and they'll be at the table at lunch if you want to talk to them.
Yep. Our quarterly forums are these half-day workshops. We've had 2 of them, and thanks to Laura and the team, all the talks are actually online, and it skews young. It's more the students really talk, and it'll give you a good overview. And I think the organizers did a great job just putting it together and like interweaving the themes, and I think you might find them enjoyable. That's one. I think another thing we're trying now, and we just started, so I don't know how well that's going to go, but we have this idea of community projects, sort of really defining 2, 3 large style things that we could really bite into and organize around a little bit. And we thought about keystone, capstone, whatever. But the community again was sort of the part that we're trying to foster, and that's really very cross-disciplinary. But we're just at the beginning of that. But we like the idea of it, so I wanted to mention it.
Yeah, in terms of what's worked well or surprising was definitely this conference on experimentation in the spring. So we're heading into the third edition of it this spring. And when we first were conceiving of any kind of event focused on this, I think there are a few motivations. One of them is MIT runs a very successful conference on digital experimentation, CODE, every fall. That's kind of grown over the years to become quite a big East Coast event. And then, we were looking at the ecosystem locally here, and of course, just with such a vibrant tech industry locally, we felt this was a topic that, really should have its own event hosted at a place like Stanford. But when we were starting, it wasn't obvious sort of what's the right model. So, we often, when academics organize conferences, we like to peer ourselves. So the initial thinking is like, let's have 9 academics or 10 academics give talks. There's another version of it where you're thinking, well, it's an industry engagement event, so let's have 10 academics, 10 industry speakers. We actually land on a mix where it's like usually about 3 academics, 6 industry speakers, somewhere in that range. And that actually has turned out to be like really good. So in a couple different ways. One of them is that the academic talks, they're really, very serious technical talks. And I think it's good for everyone to sort of see that endpoint, like where is the sort of frontier of current academic research in related spaces. The interesting thing for me actually has been the industry talks and sort of what's being brought to the table. Without exception, every single one, there's been a lot of thought put into the kind of trajectory that these researchers in industry have taken from being PhD students in an academic environment to being in a company now and working on problems that are actually impacting practice. And I think I hadn't appreciated before how seeing these alongside each other works well. And I think one other aspect of that format was just having a small number of talks, but where each kind of speaker is highlighted, actually, I think has worked well that way. In terms of what's been more challenging, I do think actually that just sort of the mechanisms for kind of fostering large-scale collaboration, kind of like what you're describing with your community projects. It's something that's been kind of on my radar screen, but I think it's hard, and it's something I would love to see us invest in a bit more. So maybe that means certain types of funding mechanisms or student fellowships that are actually bringing groups together around kind of larger thematic areas. One thing that Stanford historically, I think, has not done as well as MIT and Berkeley, for example, we tend not to be a large external grant institution in these sort of disciplines, like the disciplines adjacent to causal inference and causal science. And I think these kinds of centers open up a lot of opportunities for that type of effort. And so I think there are, I think, ways to bring larger collaboration to the table that we haven't leveraged yet. So I'd like to see that happen.
I think it's also, just to point out maybe what's obvious, is there's a lot of synergies potentially between the centers here. Some are methods-based or open science and sustainability. So I think there might be some funding possibilities
That bridge.
coming from that side. And I would say there's nothing that MIT or Berkeley do better than us. So I'm going to retract his statement.
Especially not Berkeley.
That seems like a great note to end on. So as I mentioned earlier, there will be tables at lunch, and each of the centers will have a table. So if you're interested in any of the topics that you heard today, or want to hear more about ways to get involved specifically from your research or just sort of more broadly, then please come find some of these folks, but also other people from the centers will be there as well. And other than that, please thank our panelists for their time today.